Okay, so this is going to be a very exciting video on how to do these problems. And I just want you to have a chance to see each one of them at your own pace. So I'm going to talk my way through these. It's going to be very entertaining. I always am looking to get the sign part, excuse me, not the sign part, the trig part of my equation alone. And so in this case, I'm trying to get the sign alone. So I'm going to go ahead and add my 1 to the other side. Whoa, but not with a big fat highlighter. Okay, so 8 sine x equals 4, dividing by 8, because I'm just trying to get this part alone. And now I'm done. As soon as you have sine, cosine, or tangent equal to a value, it is time to go to the unit circle. Sine is the y coordinate, and I'm looking for it to go or have a value of 1/2. So I start at 0 and I go counterclockwise because I want to be going counterclockwise because the quiz is going to prompt me to type my answers in that order. So you start looking here on the unit circle and go around. So when I do that, the first place that I see that has a 1/2 as a y or sine value is at pi over 6. And then as I keep going around, the second and last place is 5 pi over 6. Now, in this worksheet, you had an answer bank. So I'd be looking for pi over 6 and 5 pi over 6. So that is letter D. So I'm going to go back and just know that I probably did it right since it's on there. Number 2 had the typo, so this should be positive. This number 4 should not have a negative. I'm going to do the same thing. I'm trying to get cosine alone in this case. So now I have cosine squared x equals, I'm reducing that to 1/2. But this one is squared, so I need to come in here with a square root, plus or minus. That will turn this into plain cosine. The square root of 1 is 1, but the square root of 2 is root 2. This is done. I have cosine alone, but I can't leave this with the radical on the bottom since I'm not flipping it over. And so I end up with cosine x equals plus or minus root 2 over 2. This is what I'm going to find on the unit circle. But this one is a cosine, so it's looking for the x coordinate, and it can be either positive or negative. And so as I travel around the unit circle, these are the places that have an x coordinate of either positive or negative root 2 over 2. And I guess it doesn't matter since I know my answer's right, but I'll look and check and say, yep, that's correct. This is B. Okay. This one, if you don't love the look of that, you could let n equal cosine, and then you'd have 2n squared minus n minus 1, and you would need to factor that like you did in Algebra 1. You would need to find a way to make 1 at the end, which is only 1 times 1, and 2 at the beginning, which has to be 2n times n. In order to get the negative 1 that you need in the middle, you're going to need a negative 2n and a positive 1n in the middle. So setting each of these now equal to 0, I either need 2n plus 1 to equal 0 or n minus 1 to equal 0. So n has to have a value of 1, or here, take away 1, and n has to have a value of negative 1/2. But n is cosine. So I need the cosine of x to have a value of 1, or the cosine of x to have a value of negative 1/2. And that's where I go to my unit circle. I look to see where is the cosine 1 at pi. Where is the cosine negative 1/2? At 2 pi thirds, and again at 4 pi thirds. So on the quiz, I'm supposed to put them in order. So I would come across 2 pi thirds first, then pi, and then 4 pi thirds if I was making my way around the unit circle in that direction. I don't really care about the letters from down at the answer bank, so you guys can check that out if you want to. So here, the thing I'm trying to get alone is the cosecant. So I'm going to add 5 to both sides and then divide by 3. So the cosecant of x is 2, but I can't look up cosecant. So cosecant flips over to be sine secant flips over to be cosine, and cotangent flips over to be tangent. So in this case, I'm going to flip over my 2, and it will become sine x equals 1 over 2 instead of cosecant equals 2 over 1. Now it's unit circle time. As soon as I have just sine or just cosine or just tangent, I'm ready to look at the unit circle. For the places where sine, which is the y, equal positive 1/2. Where does that happen? Well, the first place it happens is at pi over 6. Second place that happens is at 5 pi over 6. World's worst 6. There we go. All right, how about 5? Well, the thing I'm going to try to get alone is secant, and then that's going to be a flipper. I'll need to flip it over and turn it into cosine, but I'm going to start by subtracting 3. So 2 secant x equals -4, dividing out the 2, secant x equals -2. Time to flip. It will become cosine, and -2 over 1 becomes -1 over 2. So now I can travel to my unit circle and look for places where the cosine, which is the x coordinate, equals -1/2. And I see that happens at 2 pi thirds and again at 4 pi thirds. All right. I see a squared here, so I'll have to be careful with plus minus. I'm not factoring because I don't have a squared tangent and a regular tangent, so I'll be able to use just a square root sign. Add 1 to both sides. Tan squared x equals 1. Introduce that square root sign. You'll need a plus minus. Squares and the root cancel. So tangent is going to equal either the positive or negative square root of 1, which is just 1. Since I have sine, cosine, or tangent, I am ready for the unit circle. And I'm using my tangent boxes to tell me where I can find a tangent value of either positive or -1. First spot I see, second spot, third, and fourth. All right, let's keep going. Here I'm looking at getting the sine alone, so I divide by root 2. And I'm kind of done, and the reason I'm kind of done is my sine is alone, but I can't look this up on the unit circle because I need to rationalize it first. So what I end up looking for on the unit circle is negative square root of 2 over 2 after I'm done rationalizing. So where on the unit circle is the sine, which is the y coordinate, equal to negative root 2 over 2? I'm looking for the sine to be negative. So that is going to be at 5 pi over 4 has a y coordinate of negative root 2 over 2, and so does 7 pi over 4. Here I see that I have secant squared and secant. This is going to be tricky for 2 reasons. One, I need to factor. So I got to bring that 2 over by subtraction so that I can have it equal to 0. And then the second reason it's a little tricky is it's going to be a flipper. I can't look up secant. I'll need to flip it over later. So how do I factor this? And again, if you want to factor it as n squared minus n minus 2, you can think of it that way and factor it accordingly. If you want to just go for it and use the secants, the only way to get secant squared out front is to have secant times itself. The only way to get a 2 at the end is to take 2 times 1. And the only way to get a negative in the middle is if this outside -2 is negative and the inside 1 is positive. Then the -2 and a positive 1 will give us that -1 that we're looking for. Now I need them to equal 0. So I'm looking at what makes this equal 0 and what makes this equal 0. So here I need to subtract the 1, and here I'll need to add the 2. But this is a flipper. So secant flips over to be cosine. When you flip -1, you still just get -1. Here, this is going to flip over to be cosine, and when you flip over a 2 over 1, you get a 1 over 2. Now I can go hunting on my unit circle, and I can look for places where the the cosine or x coordinate is -1, which is only at pi. And then the places where the cosine or x coordinate is a positive half, which is pi thirds, and also 5 pi thirds. Alrighty, almost done. I'm going to add 1. I'm trying to get this cotangent alone, and I see a couple things that are going to be tricky. 1, it's squared, and 2, it's a flipper because I have cotangent and I'll need to flip it over. So I have 3 cotangent squared x equals 1, dividing by 3. The cotangent squared equals 1 over 3. To get rid of the square, I need a root plus or minus. These cancel. Cotangent is going to equal, now the square root of 1 is just 1, and the square root of 3 is something I can't like easily find. Don't rationalize yet though, because this is a flipper. So this is going to flip and turn into tangent. And that tangent is going to flip over our old values. So instead of 1 over root 3, we're going to have root 3 over 1. So now I have to go, sorry, my computer is dying right now, so I'm trying to manage that as I make this video, and it clearly is not going well, so I apologize. So now I'm going to go to my unit circle, and I'm going to look for where the tangent equals either positive or negative root 3, and that is going to be at pi thirds. I'm using my tangent boxes so that I can find these kind of quickly and easily. And ta-da, there we go. All right, then let's take a look at the last one. I kind of wrote on it, so I'm going to recopy it down here. I need to get rid of the 4 by division. And then I need to square root, introducing a plus minus. These cancel. I get cosine x equals, now the square root of 1 is 1 and the square root of 4 is 2. So I'm good to go. This is what I need to look up on my unit circle. Any place that the cosine has a value of positive or -1. So going counterclockwise around, I see that's at pi thirds, it has positive half. And at 2 pi thirds, it has -1/2. And at 4 pi thirds, it has a -1/2 value. And at 5 pi thirds, it has a +1/2. But because we did square root, we're looking for both the positive and negative option anyway. So hopefully that helps you walk through these and kind of help troubleshoot any areas that might be giving you a little trouble. Have a great day, and I'll see you Friday.